But drilling operations must deal with not only the conditions at the surface of the earth, but also with conditions in the subsurface, where hopefully the bit is steadily drilling deeper and deeper. In general, along with this increasing depth comes increasing pressure, and controlling the pressure of the subsurface environment is a major part of the drilling operation. Let us consider subsurface pressure for a moment. Most of the sediment in the sedimentary basins in which drilling is conducted was deposited along with or later invaded by water. Therefore, the porous rocks of the petroleum reservoir and the formations above it all contain water. The fluid pressure in the pores of these water-filled rocks increases with depth, just as it would in any body of water, whether an ocean or a swimming pool. The reservoir pore pressure at a particular depth is a result of this fluid column reaching toward the surface. The rate of pressure increase, or pore pressure gradient, depends on the density of the water, and the water density depends primarily on the amount of dissolved mineral salts, that is, the salinity of the water. Of course, the load of sediment above a reservoir also exerts pressure. If we add together the pressure exerted by a column of sediment and the pressure exerted by the column of water within the sediment, we have what is called the overburden pressure. Overburden pressure increases at a rate of about 1.0 psi per foot, or 23 kilopascals per meter. About half of this increase is due to the fluid and half to the sediment. Certain geological or geochemical processes can affect the pressure gradient, causing it to deviate from its normal trend and account for a larger portion of the overburden pressure. This can happen during the rapid deposition of sediment in a basin. As sands and muds are buried deeper, the water squeezed out of the compacting mud may escape through the permeable sands. However, some water trapped in the sands has no way to escape and therefore must help carry the load of the sediment above. Consequently, the fluid pressure in the porous sandstone surrounded by shales is higher than expected. If the pressure exerted by the column of fluid in the borehole is substantially less than this unexpected pore pressure, the formation fluids in the permeable rock will flow from high to low pressure, a potentially dangerous situation. Another factor contributing to the hostility of the subsurface environment is temperature, which also increases with depth, usually about 2 degrees Fahrenheit per 100 feet, or 3.6 degrees centigrade per 100 meters. High temperatures require expensive, specially formulated drilling fluids and can seriously affect the performance of downhole equipment, weakening metal parts and causing electronics to malfunction. And, of course, the rocks themselves can make things unpleasant. Gumbo shales which stick to the drill pipe and plug bits, salt formations which ruin costly drilling fluids, and high permeability rocks which steal the drilling fluid from the hole.